Good morning, everyone. My name is Alexi. I'm the head of systems and rendering at PDFtron, and today I'm going to be talking to you about PDF versus Office and whether reliable Office rendering is possible. So just to get things started, over the course of this talk, I hope to convince you of the following points. I'm just going to say them right now, but we'll go into details of why I think these are true later on. So first of all, Office is a good format for document creation, but PDF is better for sharing, viewing, and archival. So the answer to our question about whether reliable Office rendering is true is possible is no, it is not. That's what we're going to get to. But thankfully, we can make up for Office's shortcomings using PDF strings. So PDF is better for sharing, viewing, and archival, as I said. And it's going to render the same on different devices, unlike Office. It will render the same now and in the future, unlike Office. And it makes better use of limited hardware as well. And we'll finish up the talk, going through a few workflows that make use of these two properties together. And before we start off, so I'm going to be pretty loose with my language in terms of what an Office file is. Sometimes I'll say Office, sometimes OXML, hopefully in the right context. But during the course of the talk, what I mean is basically Office is in OXML, Microsoft standard, standardizes ECMA 376 and also ISO, and the kind of file that's produced by Microsoft or PowerPoint or Excel. So here's our total roadmap. We're going to go through, we already did our introduction. We'll define our problem. We'll take an in-depth look at different aspects of the problem, look at some solutions, and then sum up. So to start off, we want to define our problem in terms of like these four operations. So we have viewing, archival, sharing, and editing. So there are a lot of Office files in the world. I mean, this format has been around for quite a long time. Microsoft Office has been around for quite a long time. People have been producing documents using productivity software for a long time. It's an important problem to solve. And we can look at this in a couple different contexts. So we can have, maybe internal to your own company or document management system, you have an internal process. And, we can edit documents. We can then perhaps collaborate on those documents and then maybe archive them. And then we can maybe edit them again or collaborate them from archival. And we still have the same basic operations here. We're still viewing, we're still archiving, we're sharing, or we're editing. Of course, if you're looking at making some sort of user-facing app, then it's a similar sort of problem. In that case, you have a lot of documents that have been out there for forever in the world. Your users have them, they've been creating them, they're still creating them. And it's your job to process those documents and perhaps to view them or perhaps to enable workflows in which other people can share those particular documents or collaborate on them. And again, we have these same basic operations. And so what I'm trying to claim here is that whereas Office is quite good at editing, it's not really that great at the rest of them. So now we're going to take a look at why that might be the case. So this next section will take place in a few different parts, and I'm going to try and intersperse this with basically facts about the formats that are commonly known, as well as the implications of those facts. So here we go, our fight night. Although it's the morning, but whatever, close enough. So I've been the lead developer on on PDFtron's Office conversion product. We have a conversion product that we've developed entirely in-house. So all our technology is basically all our technology within this converter. And I've been the lead developer on that for 5 years now. And so I hope to share with you my experiences, basically. Well, let's just get into it. So first of all, this is non-contentious. We have PDF, of course, is a fixed format. Office is reflowable. And by fixed, I mean that each element on a page is independent. So we have, element A over here, element B here, When you lay out element A, it does not change the position of element B. You always have some well-defined formula for determining where these elements are. They're easy to place. Reflowable element or layout is slightly different in the sense that element A and B and C and D and so on go on top of each other. And so when you're looking at element M, then you need to look at element A through N and determine how much space they took up, where they were on the page, in order to find out where your later content should be placed. And again, non-contentious. If you look at the file formats themselves, PDF is just it's a single flat file, and within that flat file you can have binary lookup or file offset lookup. Let's say you can jump to any position in the file, and you can jump to any page within the file, generally with a few intermediate steps. Office is slightly different here. So first of all, we have a zip package, so that is one file. And within that zip package, yes, you can jump to one part of the zip package. But if you look at something like Microsoft Word or Office ML, then in that case, or I should say word processing ML, my mistake. In that case, all of your content is within one single XML file. So you have a 600-page document. Generally, it will be in one single XML file. And you can't randomly access within here. So if you want to look at page 599, you need to read the entire file. If we take these two things together, now this is maybe going to be a controversial statement, but especially considering our previous talk about SIMD rendering and all this, I am looking here at an imaging model that's compatible with Office. So nothing complicated. If you want to look at your 18 nested transparency groups and arbitrary PostScript functions for every pixel on the page, then yes, PDF can take a long time. If you're looking at purely Office-based content, then PDF is actually very good here. Office is quite CPU heavy in the sense that when you lay out your 600-page document, generally that has to be done in one chunk. You'll read through the entire thing, you'll lay out the entire thing. And if you want to look at page 300, you definitely need to do page 200 to 299 first. This is not the case with PDF. PDF, if you want to render page 300, you just look it up, you render it. This basically makes it's possible to render more quickly, and it's possible to offer a better user experience using less CPU power. And you can argue that it doesn't really matter these days, and CPUs are pretty fast. But generally, when you talk about CPU power, it's easy to talk about. Basically, you can draw an equivalence to battery life. So more CPU power, more battery usage. Or if you're looking at rendering something purely client-side on the web, performance here is still, absolutely critical. Not to make things totally unfair, Office does come out on top here for editing content. Reflow is critical here. When you edit a document, people take it for granted in productivity software. If you insert a paragraph at the top of your page, then it's going to push a paragraph off the bottom. That's going to go to the next page. It's going to continue this, so you push this on page 2, all the way down to page 600. Your entire document just works. If you do this with fixed layout without a lot of software assistance, well, basically people don't do this because it's a giant pain. You wouldn't want to do this process manually. So Office is definitely, the format itself is well suited for quick and effective editing. And now we get to the crux of the issue here. So Office rendering is unfortunately unreliable. And when I talk about unreliable, what I mean is inconsistent. When you view a file on one platform versus another platform, you're going to get different results. We'll get into why now. So first of all, this is like just a basic example, totally built into the format, nothing controversial. Both PDF and Office files, you can either embed a font or you can not embed a font. With Office files, generally, fonts are not embedded. With PDFs, generally they are. There are a number of reasons for this. A lot of it has to do with permissions and fonts. If you're going to, Office files are meant for editing. So if you embed a subset of a font within an Office file, I only need the letters, P, D, and F, and you give that to someone else, well, they can't actually make any more letters using the same font. So you have to embed the entire font, and you have to embed it for editing. And many fonts they don't actually allow this through permissions. It amounts to sort of a cultural thing. Generally, Office files do not have fonts embedded within them unless people try very hard to do so. And PDFs generally do, unless people try hard not to do so. Now, even if you have a total, even playing field, and you're looking at files in which fonts are not embedded, in a PDF, at least you're going to have the size of your font. So you know how big each glyph is supposed to be. And you know where it should reside in the layout, how much space it takes up. Office, unfortunately, does not give you this. And so this leads to a sort of familiar situation. I think everyone who's used productivity software has seen something like this before. So here we have Alice, who's created this lovely document here. And she's used the font Californian. This font comes with Word. It looks, well, it's a serif font, and I'm going to say it looks to layperson a little bit like Times New Roman. And I'm sorry if there are any designers in the audience. Going back to David's talk earlier, it is not at all like Times New Roman, but it could look like it. And it happens to match well with this unicorn. Alice then, as a normal person would, she decides, well, this picture should be about as big as it can be, expands it so it fills a page. Great. Now she sends this document to Bob, and Bob wants to view the document. And unfortunately, on his system, he does not have Californian. But his rendering software does a pretty good job and decides, well, yes, it looks like Times New Roman. I'm going to use that instead. So you might say, well, it looks somewhat similar. Unfortunately, Times New Roman is just a little bit taller than Californian. And all of a sudden, you have a document that looks quite different. Maybe 14 points difference in the height of that paragraph, and now something's been pushed to an entirely different page. And unfortunately, reflowable, if you take the combination of pages and reflowable layout, you end up with a situation quite often. Small changes leading to large divergences in rendering. Now, sometimes this can actually be like a pretty big deal. Like if you imagine this was like, just about anything. You can imagine there's a job application. Someone submits something and it's supposed to look one way, it looks another way. Well, they're going to be disappointed. They come across as less competent through no fault of their own. It can be more important than that. Maybe this is some sort of legal disclaimer that was supposed to be on this page and all of a sudden got shoved to the next just because someone didn't decide that they wanted to send out the document in a more appropriate format. So in general, this problem is sort of unavoidable, like small differences leading to large changes with reflowable layout. But you don't have to take my word for it, or your own even. We can just ask everyone. And as Google says, a Word file looks different on another computer. This is totally not contrived, the only result that came up. It happens a lot. So I'm going to follow up this argument, which is something that was built into the format, that fonts or small changes from fonts and reflowable layout leading to changes. And I'm going to say that basically Office rendering will never be stable in the sense that it will be consistent on more than one platform at the same time. And this is almost built into the format. And the reason for this is that it's so huge, and there's a lot of aspects of the rendering that are totally undefined. So if you look at the PDF standard, 1.7 was 748 pages, 2.0, 950 pages. And this, again, might be contentious. We'll leave out complicated imaging models, especially transparency groups. But I would say that if you took someone who was sufficiently motivated, another person who was sufficiently motivated, put them in two different rooms, had them come up with a renderer from the spec with nothing else, that you would end up with something that was reasonably similar. Given the same document, their two different clean room implementations would generate similar output. certainly semantically similar. Now, if we look in contrast at Office, if we look at the ECMA 376 4th edition, we have about 9,000 pages here. And I'll be referencing the ECMA standard just because it's publicly available. You can go and look at it without paying any money. It's functionally the same as the more recent ISO standard. So it's huge. Like, there's a whole ton of information in there. And certainly everything that's supposed to be in an Office file is accounted for in the standard. But unfortunately, what it doesn't give you is any information about rendering itself. So yeah, I would say it's woefully incomplete, unfortunately. So if you took a clean room implementation of it, you put one person in one room with these 9,000 pages, and I'm sorry for them, and then in the other room, the same 9,000 pages, you would end up with something that certainly they could read everything from the Office file, but they wouldn't be able to come up with something that was visually similar. You wouldn't have the same elements on both pages. You wouldn't. Well, there's a whole bunch of differences, and I'll go into some examples. So one of these what I would call undefined behaviors in the spec has to do with floating content. But this is a little combination. It's undefined, and it's also kind of difficult to do. So floating content, what I would call floating content is something where you have the reflowable content on the page, your normal text, and you also have special fixed elements that can be, in a particular position. And in this case, we're looking at the case where the reflowable content can go around the floating content. So Office actually has a very rich model of doing this. You can do it in a whole bunch of different ways. There's, you can make documents that look like this. If you look at HTML, they probably wisely decided not to go with the same number and richness of features, and you can't do content that looks like this. And this puts a very large burden on implementers. They're tempted to take shortcuts or to do things in different ways, and you end up with situations like this. So we have, on the left, we have MS Word 365 for Windows as a new version. Alice, the poor soul, has made a new document, and this time she has tried to highlight a particular part of the document by saying, this part is important, using one of Word's or Office's floating content, methods. And so we see that this text here highlighted. Okay, we take the exact same vintage of MS Word 365, but this time the online version. You just take the same file, you upload it. You end up with a very different looking document, and so that they've neglected to actually process the floating content in the content wrapping in the same way, and they've moved it as well. And you end up with what I would say is a semantically different document. And this might look contrived, but what if this was an initial, So I'm supposed to initial this part, and all of a sudden you're initialing something different. And you might say, well, what if it's just floating content? And unfortunately, that's not the case. So here, this is over my 5 years of working on this project. Off the top of my head, I just started writing these down, and I came up with this list of things that I would definitely consider undefined in the specification. How are you supposed to actually render something? So float placement, as I mentioned. When do elements overlap? When do you consider a character overlapping with another character, or maybe a shape, or a paragraph, or an isolated line? The rules are all different for all of these cases. What if you have a table? Table with a cell with another table in it, with another cell in there, with another table, and then that goes across a page. Which parts of that go on each page? Unfortunately, this is undefined by the spec as well. And let's move on. I'm not gonna subject you to this entire list. We'll go with one particular story instead. So recently we had a customer who quite reasonably wanted to view PowerPoint animations in PDF. And not in the sense of having actual animated PDFs, but they just wanted it so that every time you would click on your PowerPoint animation, that should generate a new page in the PDF. And I thought, well, okay, let's see how we would do this. And having learned over the last years, I did not go to the specification first. I just tried it out. So make a file in Word, simplest thing you can imagine, one title slide or one title that fades in over half a second. And so for anyone who's worked with XML before, I'm sorry. And also, this is going to look weird. Like this is a lot of XML, even for OXML. So if you look through this entire thing, you find down here, you have anim effect, transition in, filter, fade. Okay, that sounds correct. We know what's going on here. But then you look at the rest of it, and you're, well, why do they need 18 levels of nested nested XML? But you can work through it, and there's some nested lists here, and animations need to occur in some context, and okay, we can figure this out. We can imagine what they were going for. And then you think, well, okay, I need to know a little bit more. So let's look at some of these attributes. So here we have something fill equals hold. And you think, well, okay, that seems like it could be important. Let's look it up in the spec and see what it actually means. So fill, this attribute describes the fill type for the time node. Okay, it's not the most helpful thing, but it does reference another type, which is more helpful. So this simple type specifies what modifications the effect leaves on the target element's properties when the effect ends. So that may be enough to, maybe a little bit too much to parse at first glance, but so if you animate something from here to here, what happens at the end? Does it snap back to the start? Does it stay where it was? That's basically what this is describing. You say, okay, great, this is helpful. Now what else do we have? We have 4 different choices. Okay, I came up with 2 on my own, and they seem to be here. There's 2 more, and that's it. There's nothing else. You're stuck. Well, you're not stuck. You can definitely figure this out, but you're looking at a lot of work. And this lot of work applies to basically everything in Office. And so if you're looking at different Office implementations and thinking, are they going to do all of the stuff that is in the format? Is it all going to be there? Are they all going to go through this work? Probably not. So I would say that, if you have Alice and she sends out her documents to a whole bunch of Bobs, they're going to be on different renders, especially these days when web platforms are becoming more popular, mobile as well. And she has no guarantee that any of them are going to look the same. First of all, what she made and what they see is different, and they see something different as well between them. And so I would say at this point, our conclusion would be that we should use PDF instead for reliable rendering because it just doesn't have this problem. Right, so as I said, PDF for sharing, archival, viewing. I'm going to mention here that I would consider archival like a special case of sharing. You're sharing with yourself in the future or someone else in the future. Very similar to actually just sharing with someone else. So now we're going to look at what do we do, basically? Where do we go from here? So is reliable Office rendering possible? No, but fortunately, PDF is good at the things that Office is not good at. So we can create workflows that sort of combine the strengths of these 2 formats. So let's take a first crack at it here. So in our first workflow, we're going to look at maybe a larger company. They have their document management workflow. And the idea here is that let's go through this. You have a user, they create a document using a productivity software, and then they convert that themselves. So, the onus is on the user to, perform their editing and then save as a PDF and then transmit that to the rest of the company into the document management system, after which it can be viewed by others and collaborated on. Maybe feedback would go back, and then we do the same cycle again. So this is, this would definitely work. We at least do not have the same, everyone is going to be looking at the same thing, at least in this case. Unfortunately, this does rely on policy rather than technology. So you have to make sure that everyone who is using productivity software does the conversion and does it correctly. Are they embedding fonts correctly? Are they using the correct versions of Word to do this? And that's a large burden. I mean, that's a big deal. It's very easy for policies to slip, and it takes a lot of work. First of all, for everyone to do this. Every little minute counts when you're going through your workday. And enforcement of policy and creation of policy is also, expensive in the sense that it takes effort. It's inefficient. So that is one possibility, though. At least we will be reliably communicating. Another possibility here is that we can just use central conversion. So users would, instead of converting to a PDF and sending that to the document management system, we'll get the document management system itself to do the conversion. So unfortunately, we can't use Office here. Or at least we probably shouldn't. So Office itself, it can't run on Linux servers. Most servers, or many servers these days, of course, are Linux or some related variant of it. Even if you do have a Windows Server environment, then it's pretty unreliable in that case. Office was never meant as a back-end application. It's a GUI application. And even if you automate it, it still tries to do GUI things every now and then. Its threading model is not really compatible with servers. Occasionally, it tries to give you pop-ups to ask for confirmation on a headless server. And it does use a lot of resources as well. And even if you are okay with all of that, if you look at the licensing for Office, it's not especially clear that you were actually allowed to use it on servers at all, which is a hurdle that many people don't really want to cross. And of course, you can't put it in your own app. Office is a standalone application, and you can't wrap it in your own application. So with that said, we're going to have to use some sort of third-party software here. And what's going on is we have the same thing as before. We have a person editing their document. They send it into the central service. This time it gets converted centrally. And so we still have, at this point, a potential for divergence. We are converting from Office. We're converting to PDF. And we need accurate conversion at this point. But we'll push that problem aside for a second. Once we have done that, once the document is in the system, we're at that point totally assured that everyone is at least looking at the same thing. So there is a possibility of divergence here. But once we go into here, we are now collaborating effectively. To go back to David's analogy with the packets, if you're trying to collaborate on two different documents and two people are seeing different things, you have effectively malformed packets. The communication doesn't work. And so this workflow solves that problem. Also, now that we're not using MS software, we can embed it in our own software. And so you have the possibility of taking in external documents, converting those within your own software as soon as they hit your system, and then pushing those into the server. So this basically takes load off the server. That would be the advantage of that approach. And so what we need here to complete this picture is essentially just we need some way of assuring that our conversion is accurate. And so that sort of raises another problem, which I'll leave for another talk. This is something that we are actively working on at PDFtron. And we're really happy to talk about it at some point, but not quite yet. And it's basically, how do we quantify, accurate conversion? How do you take some sort of any solution essentially, and put a number on, how reliable do I think this is, given some subset of documents on all documents? It's a difficult problem and something that probably needs to be solved in order for this to be a totally bulletproof system. I think there's another solution to this problem too, though, which I'm going to pick on MS a little bit here. They have made a format which essentially makes it difficult to communicate between different parties. And it just doesn't include the necessary information to make sure that your visual information is represented properly. And I think they can probably go a little bit further. And if we, maybe we take something like OXML-A. What if they embedded fixed format within the Office document? As an automatic thing. You could take this really easily, like OXML is a package format. You could just shove a PDF directly in there. Of course, I don't think anyone's going to be super happy with that solution altogether, but it would be possible. And I think that for Office to be a good citizen in today's communication market, I think this would be a very positive step that they could take. And I think any one of us here would be quite happy to help them. I know I would be. So on that note, thank you very much for your time today. And,